J-pole antenna is quite popular among radio amateurs for 2 meter and 70 centimeter bands, that is the VHF and UHF bands. It consists of two segments, one 3/4 wavelength segment and a matching stub, which is a parallel shorted matching stub of quarter wavelength. The portion above that is corresponding to the portion beyond the quarter wave, will be a half wave. This is a half wave, and another quarter wave is attached here. And for this half wave antenna, up to this, when the coax is fed here, it can be considered as a unfed antenna. Unfed antennas have high impedance, and this requires a matching. So this arrangement of the J-pole is mainly for matching. You have connections from the coax on either side, and the connection point has to be adjusted by sliding up and down to have the lowest SWR. That is how the J-pole antenna is tuned. This region between the two elements, matching stub and the main element, should be less than 2% of the wavelengths. And the whole assembly should be away from conducting material. You should not have metallic structures near this. If you are using a galvanized iron pipe, as is usual among us radio amateurs, then a section of non-conducting material like a wood piece or PVC pipe has to be attached below the antenna, between the antenna and the mast. And the length of that should be at least about 3 times of this separation between the two elements. And there should not be any other conducting material near this, like a window grill or another mast should not be very near to this antenna for best performance. And J-pole antenna has a little higher gain in the direction of the quarter wave matching stub. And this antenna has been used for terrestrial communication through repeaters and simplex operations, as well as for satellite communications. In satellite communications, if you have a VHF antenna, usual amateur band for UHF, ultra high frequency, is on the third harmonic of our VHF band. In satellite communication, usual amateur 2 meter band and amateur 70 centimeter band are like third harmonic. That is, a 2 meter antenna will also resonate as third harmonic on the 70 centimeter band. So this can be used as a single antenna for satellite communication for favorable passes. This is just like you use a 7 megahertz dipole antenna for 21 megahertz also, with a reasonably good standing wave ratio or SWR. Similarly, this can work for as a dual band antenna also, though not optimal. And it is also mentioned that when you use J-pole, 2 meter J-pole for 70 centimeter, the angle of radiation is not ideal for terrestrial repeaters or terrestrial communication, but it is okay for satellite communication. A slightly different angle of radiation directed towards the satellite is there compared to that of the terrestrial repeaters. So a single J-pole antenna on 2 meter has been successfully used for satellite communication for the crossband repeater. You know that International Space Station and many other satellites have VU transponders with uplink on VHF and downlink on UHF. So if single antenna works for both, that's convenient for the operator. That's meant for those who are operating using base station from within the shack. This diagram shows the current and voltage pattern, that is the RF current, not DC current, RF current pattern in the stub and the other main segment of the antenna. You can see that the current is peaking at the lower end and also at the quarter wave region. This portion will be a quarter wave. Peak is at lower end and also at the quarter wave segment. And at the top, the current is minimum, RF current is minimum. Voltage is the other way around. Voltage is maximum at the upper end and for the lower 1/3. Here also the voltage is peaking. And in case of the quarter wave step, voltage is peaking at the upper end and current is peaking at the lower end. This is the current pattern in the two regions of the J-pole antenna. This diagram illustrates the radiation pattern from a J-pole. So as you can see, slightly higher towards the matching stub region. And a slightly higher angle would mean that it will be directed towards the sky partially, and that is how this is useful in satellite communications. You want the radiation to be slightly on a higher angle towards the satellites in the sky. Of course, a single J-pole antenna is not the ideal one for satellite communication because this will not have a high gain, and being omnidirectional, the whole of the radio frequency which you radiate from the J-pole will not reach the satellite. Only a small fraction will reach the satellite. Unlike in case of Yagi antenna, which has a high front to back ratio and directivity, most of the signals would reach the satellite. While here, as the radiation pattern is omnidirectional, only a small portion will reach the satellite. But still, this is a compromise antenna for satellite operation because you don't have to rotate the antenna. If you don't have an antenna rotator, Yagi antenna will work only during a very small portion of the satellite pass, while J-pole will work almost throughout the pass. So rotator is not needed, or rather other way around. If you don't have a rotator, you can consider J-pole as a compromise antenna for satellite operations. Then a single antenna for both UHF and VHF is also a compromise. Ideal would be to have two J-poles, one for UHF and VHF, and then connect with a diplexer to the radio. But all getting things complicated for a beginner in satellite operations. With the J-pole, you may be able to operate some of the good passes of satellites, but no low elevation passes, and also you are unlikely to get any DX using an omnidirectional antenna unless you are lucky to be on the top of a high-rise building at a high altitude, and then you might be able to work. If you are on a mountain, on a high-rise building, even a J-pole, you could work comfortably a lot of DX. That's a very rare situation.